In the early 1940s, the world's greatest scientific minds came together to develop the most powerful weapon in human history, the atomic bomb. The Manhattan Project was not just a military operation. It was a scientific revolution. It brought together physics, chemistry, engineering, and espionage, changing warfare and global politics forever. How did the U.S. create an atomic bomb from theory? What role did espionage and secrecy play? And what were the ethical consequences of unleashing nuclear power? Today, we take a deep, level dive into the Manhattan Project, science, and the atomic bomb. The origins of the Manhattan Project lie in the discoveries of the late 19th and early 20th centuries. Scientists like Marie Curie, Ernest Rutherford, and Niels Bohr unlocked the mysteries of the atom. By the 1930s, physicists realized that splitting atoms' nuclear fission could release enormous energy. Then, in 1938, German scientists Otto Hahn and Fritz Strassmann discovered uranium fission. This breakthrough meant a nuclear bomb was possible, and Nazi Germany had a head start. Alarmed, physicists Albert Einstein and Lascelles Aard wrote a letter to President Franklin D. Roosevelt in 1939, warning that Germany could build an atomic bomb. Roosevelt acted. In 1942, the U.S. launched the Manhattan Project, led by the Army Corps of Engineers and a team of top scientists. This was the birth of the nuclear age. The Manhattan Project was a massive multi-site operation. It had 3 key locations: Los Alamos, New Mexico, the secret lab where scientists designed and built the bomb, led by J. Robert Oppenheimer; Oak Ridge, Tennessee, where uranium was enriched using gas diffusion and electromagnetic separation; Hanford, Washington, where reactors produced plutonium through nuclear chain reactions. The science behind the bomb was groundbreaking. Physicists had to enrich uranium to 3.5, separating it from uranium to 3.8, an extremely difficult process. Create plutonium to 3.9 through neutron bombardment in nuclear reactors. Develop an implosion mechanism to compress plutonium into a supercritical state for a controlled nuclear explosion. The result? 2 bomb designs. Little Boy, the uranium bomb, using a simple gun-type mechanism. Fat Man, a plutonium bomb, using implosion to achieve a nuclear chain reaction. By 1945, the bombs were ready. On July 16, 1945, in the New Mexico desert, the world's first nuclear explosion took place, the Trinity test. As dawn broke, a blinding flash lit up the sky. The explosion was brighter than the sun, and the shockwave was felt over 100 miles away. Oppenheimer, witnessing the blast, famously recalled the words from Hindu scripture, "Now I am become death, the destroyer of worlds." The bomb worked. The United States now had the ultimate weapon. But would they use it? By mid-1945, World War II was nearing its end, but Japan refused to surrender. The U.S. faced a difficult choice. Option 1, invade Japan. But estimates suggested millions of casualties. Option 2, use the atomic bomb to force a quick surrender. After Germany's defeat in May 1945, President Harry Truman decided to use the bomb to avoid a prolonged war and send a message to the Soviet Union. On August 6, 1945, the Enola Gay dropped Little Boy on Hiroshima. The explosion killed over 80,000 people instantly. 3 days later, on August 9th, a second bomb, Fat Man, was dropped on Nagasaki, killing 40,000 people instantly. On August 15, 1945, Japan surrendered, ending World War II. The Manhattan Project changed everything. The world had entered the nuclear age. The bombings left Hiroshima and Nagasaki devastated. Survivors, known as Hibakusha, suffered from radiation sickness for decades.